Hello everyone. Today, in STA, we will talk about subbasement modeling. There are 3 types of subbasement modeling in STA. The first of these is modeling with continuous foundation, and the second is modeling with tie beam on raft foundation. The third is modeling with separate story definition, using panel elements on raft foundation. Now we can start modeling with continuous foundation. I have prepared a simple 3-story model. This way, our subbasement height will be 80 centimeters for this. I go to the story definition section and mark 80 centimeters. The story heights will be approximately 3 meters each. As you can see, our values have indeed changed. I'm closing. Now let's move on to continuous foundation. Modeling in continuous foundations. E indicates height. E indicates width. DH, the subbasement height. BH, subbasement width. So, it is the width of the foundation beam. Our depth will be 1 meter. Widths are 80 centimeters. Let's make our other settings. Our level will be as high as our foundation height. So I am taking X as approximately 1 meter, DH, which is our subbasement. Height will be 80 centimeters. The width is approximately about 25 centimeters in length. Let's start the modeling. Continuous foundations are modeled as monolithic. In this way, now let's enter the cantilever lengths. 40. We start by measuring a length of 40 centimeters, followed by another 40 centimeters, and then yet another 40 centimeters. This gives us 3 segments, each measuring 40 centimeters. Now, let's move on to determining our offsets. To do this, we will enter the offset values from the designated DHXY section. This section is crucial for ensuring that our measurements are accurate and aligned with the required specifications. After entering the offsets, we can confirm that our modeling process is complete. The modeling process involves several steps, including initial measurements, offset calculations, and final confirmations. Each step is essential for achieving the desired outcome. By following these steps meticulously, we ensure that our final model is both precise and reliable. The DHXY section provides the necessary parameters for our offsets, making it an integral part of the process. With all these steps completed, we can confidently say that our modeling is now fully complete and ready for further use or analysis. Now we are currently entering the subbasement floor. We are adding concrete slab. An unreinforced slab was automatically provided. Select 12 centimeters. Determine my loads and start the definition. As you can clearly see, it is not at the 0 level but at the 80 centimeters level. The reason for this is that it is actually not at 0.8 here, as you can see. Indeed. This is how the continuous foundation and modeling are done now. Let's move on to our raft foundation example. Yes, let's start modeling our raft foundation. Let our foundation height be 40 centimeters. Our foundation bottom level needs to be minus 40 centimeters. The reason for this is that the bottom end of our columns must always be at the 0 level. We are drawing our foundation. Now, let's model the tie beams. Our width is 25 centimeters. Our height is 80 centimeters. And it needs to be in a passive state. It is only selected as active in isolated foundations. Yes, we have definitely drawn the tie beams. Now let's arrange the floors. We are modeling our slab again. It came automatically. Plain concrete. We are entering our loads. We have defined it this way. Now, soil loads will affect our foundation. The weight of our soil load is approximately 1.8. A load will be applied to the square meter as approximately 1.8 times, about 80 centimeters. This results in a load of 1.44 tons per square meter. You can enter this as a live load if you want. Alternatively, you can also enter it as a dead load. This is our water pressure modeling. Now, I will show the modeling with panel elements as a separate floor definition. Yes, we made adjustments to our model. We deleted the tie beams. We deleted the sub-basement slab and added a floor. Now, we will make some adjustments on this floor. We are removing the slabs and beams in between. We will convert the entries here into panel elements. Our sub-basement height should be 1.5 meters, so we write 1.5 here, 3 meters. Let it continue. Now we come to the first floor. We select our slab, plain concrete, 12 centimeters. We are entering our loads. In this way, we have modeled our sub-basement as a separate floor definition. So, in which situations should we use this if our sub-basement height is more than 1.5 meters, meaning it can function like a basement? We can do it this way. This is a suitable solution for us. Now, we will re-examine the analysis results using our second example and our most commonly used example. Let's enter our values into the model this way. I am entering completely random values. This is not a real project. You should adjust your own project according to the information I provided. I am analyzing. Yes, our analysis is complete. Now, we will examine the first floor columns. In our analysis, we click on our column, the critical height of the HK column, the axial deformation height of the column is taken as 3 meters, 80 centimeters. That is, the sub-basement height has been added to the floor height. In the column shear force, the sub-basement height is 80 centimeters. The height of the beam on the upper floor is 60 centimeters. And when we subtract these from 3 meters 80 centimeters, we can see the LN length as 2 meters 40 centimeters. In the column shear force calculation, LN length is used and the sub-basement is taken into account. Now, let's move on to the drawings. We are making our selection in the sub-basement reinforcement drawing, and you can see our constrictive reinforcements here. Additionally, we can change our reinforcements ourselves from this section. As you can see, our reinforcements have changed. Now, let's move on to the specific and detailed aspects of the column, which are crucial. This setting is related to whether or not the sub-basement is taken into account. Let's start the calculations without considering it. I only want the first floor. As you can see, the reinforcement splice is in this area, so the sub-basement has not been taken into account. We are currently in the process of making significant changes and updates to our existing settings and configurations to improve overall performance. As you can see, the column extension was created by taking the sub-basement into account. I wish everyone good work.